Hey guys, in this video we're going to look at some more properties of logarithms beyond the basic ones that we've already taken a look at in section 4.3. You can use those properties in some of the things that we'll be doing in this video, but these are the main properties that we're going to be working with today. Alright, we've got the product property. If you have the logarithm of a product, a times b in this case, that's our argument right there, okay? It can be written in expanded form as the logarithm, as the sum actually of the logarithm of the two factors, natural log a plus natural log b, and you can substitute whatever logarithm in here you need. It doesn't have to be logarithm, it's just the easiest one to type, okay? And then for the quotient property, very similar. Natural log of a quotient, a over b, is equal to the natural log of the numerator minus the natural log of the denominator. Now these two can be combined and can actually be done at the same time as you're working through the problem, and I'll show you a little bit more about that when we look at a couple problems, okay? Our last property is the power property, and it states that if your argument has an exponent, you can bring that exponent down and multiply it as a constant multiple by, or not necessarily a constant multiple, it can be a variable also, will be a variable also, multiply that by the natural log of your argument, okay, your argument space. Alright, so these can be used in two different directions, okay? When we're expanding, let's see here, thought I'd already done this little thing down here, but I haven't. If we're expanding, then we're working this direction, okay? We're taking a logarithm with a more complicated argument, the multiplication, the division, and you can have more than two terms, okay? You could have 15 terms, or 15 factors there if you needed to. You'd have 15 different logarithms added together. You could have several on top, several on the bottom. The thing here to remember is any variable on the top, or any part of the numerator comes down as a positive natural log, and any part of the denominator comes up as a negative natural, or any kind of logarithm, okay? So expanding, we go that direction, and then condensing, we go back the other way. Didn't leave myself enough space. Go back this direction, okay? So we're getting smaller as we condense, and there are applications of both of these. We'll be using some condensing in the logarithmic equations that we take a look at in section 4.5. Expanding we use a little bit here, mainly in this section, but if you're going on to calculus or business calculus, you will see it more there, okay? So let's take a look at a couple of examples, see how we work through it. Let's see. These are my expanding examples here. Instructions in the book are wordier than what I've given here, so you may want to take a look in the book at the way they're worded. Expand the logarithmic expression. Use the basic properties to evaluate if possible, and we'll take a look at that in a minute, because we'll see one where that happens. All right, for this first one, first thing I want you to notice is we do have a root, okay? But as you know, as we've talked about, roots can be expressed with powers by using a fraction exponent. So let's rewrite that as log base 4 of x squared times y to the 1/2 power. So both of our factors have a power. The x has a power, so does the y. We'll have to take those down in a minute with the power property. I don't have a fraction, so there's no denominator, no quotient rule. It's all product and power rule, okay? So first we'll use the product rule, and we'll split those up. Log base 4 of x squared plus log base 4 of y to the 1/2. If you do have a base, a visible base like we do here with the 4, be sure you write it down. Don't forget it. I'm bad to do that myself, so definitely want to remind y'all. Maybe I won't forget to do it in the video. The next step is to take these two powers, these two exponents, and bring them down in front. We're using that power property. So you're going to have 2 times log 4 of x plus 1/2 times log base 4 of y, and that's fully expanded, okay? And in this particular one, we don't have anything that needs to be evaluated. We'll talk about that in a minute when we get to one that does have a term that we can do some evaluating with. All right, let's move down to our second one. Now this one's a little bit more complicated. We've got a lot of stuff going on here. You've got this numerator, which appears to be a difference. You've got a denominator with a factor here, and another factor here that's a binomial, okay? I don't have a property that breaks up addition and subtraction. We do have the properties that break up multiplication and division into addition and subtraction, but we don't have an addition and subtraction property, okay? So those can't be broken down. They are as broken as they can be. So I've got one factor on top and two on the bottom. All right, this is log base 11. I know that looks kind of funny. So what we'll do here is, we will have 1 from the top, log base 11 of x minus 6. That's out of the numerator, okay? And then I have 2 of them in the bottom. Now you can do this with the difference, the quotient rule, and then split that up with the product rule farther. But you'll have to remember to distribute the negative. So it's actually easier if you'll just remember that the ones on the bottom are going to be negative logs. It's a little faster and helps you remember the rule, because that way you're really only using one rule, you're not using 2. And I really didn't leave myself enough space again, so let's scoot over just a little bit. Okay, so we've got powers on 2 of them that will need to come down too. Let me see if I can write a little bit smaller. It's kind of hard to do with my finger. Like I said, that can't be broken down any farther. We can pull the 3 down. It goes behind the negative, and then I can bring that 2 down also. And again, this part can't be broken up either. Okay, they're all base 11 logarithms, and we have 3 total. The one from the top's positive. The 2 from the denominator are negative, and that's your fully expanded form. All right, let's take a look at our last one down here for the expansions, then we'll look at some condensing problems. Okay, now notice what we've got. We've got an e to the x and a y, so that's 2 separate factors on top, and then I've got a z times x minus 6 on the bottom. That's 2 separate ones on the bottom. So when we break it up with the quotient and product rule, we'll have 1 positive natural log here, 1 positive natural log there, 1 negative natural log, and another negative natural log. It's almost like you're distributing the natural log. You're really not, but it kind of feels that way. And as you distribute, what you're doing is you're turning numerators into positive logarithms and then negative logarithms from the denominator. So let's see what we get here. All right, so natural log of e to the x plus the natural log of y, both of those are from the numerator. From the denominator, we get a natural log of z, so I've got a minus in front of that, and then another minus in front of natural log of x minus 6. We do have the 1 exponential, but I want you to notice another thing about that. This is natural log e to the x, okay? That is a version of Rule 3 from section 4.3 that says log base b of b to the x, whoops, punched the wrong thing, is equal to, shoot, that threw me off. I don't know if y'all saw that slide come up or not, but I hit the thing that you use when you share the video, and so like the YouTube and all that stuff came up. And so it threw me off a little bit. All right, so that's going to be just equal to x. All right, well, there's a natural log version of that too. The natural log of e to any power is equal to that power. Okay, so in this case, that's a carbon copy of that rule. So that means we can evaluate that and get an x right there. Seems a little weird to knock the natural log off, but that is what happens. And that's an example of one where you do some evaluating. Okay, it's not the only time that will happen, but it's a good, good thing to see, because you will see some e's around. Anytime you've got a number, just a number, not something like this, but just a single number, e or 6 or whatever it happens to be as your argument, you need to investigate and see if you can actually simplify it. Okay, because it may turn into a 1, or you may get an exponent like we did here. And there's nothing else to expand, so we are done with that one. And that's the last of the expansion problems that I want us to look at. Next, we're going to take a look at going the other direction and look at some condensing. All right, let me pull that down a little bit. And again, the instructions are a little different from what you'll see in the book, so be sure you take a look at them there. We're going to condense the logarithmic expression and then reduce the argument if we can. Now, these go back together the same way they expand. If you've got an exponent, you pull it up from the front. Okay, it's going to look like a constant multiple right now. You're going to pull it up as the exponent. Then anything that's a positive log, those arguments will go on top. Negative logs will go to the bottom. So look real careful at this first one. This is a positive, and that one's a positive, and in the middle we have a negative. So the one from this one's going to go to the bottom in the argument. These two will stay on top. All right, so our first step is to pull those two exponents up. We're just using the power property of logs. Okay, you can go ahead and write that as the z to the fourth root of z is what I'm trying to say. Since that is a fraction exponent, you can write it that way if you like, and I will do that at the end. Now I'm going to start putting it together. I'm going to have one log, and it's base 10, so I don't have any little base to write. And I'm going to have a fraction. I got two things on top, x, and the fourth root of z. You will usually see those rewritten as the root, okay? Then in the denominator we just have the one thing, y squared. And that is our totally condensed logarithm. We take it back to one logarithmic expression with no leading coefficients, okay? And what you'll notice is they look kind of like the problems you started with when you were doing the expanding. All right, one more of those. Again, I've got two things on the bottom. Whoa, wrong thing. I keep clicking that instead of the laser pointer tab. Clicking the pan instead. Alright, so what we see is one that's going to give us a natural log on top. I don't have any exponents to pull up, so we can start with the product and quotient rules first. We're going to get x squared minus 9. That's the only part of the numerator we have. And then y times x plus 3 on the bottom. I can factor the numerator. X plus 3 times x minus 3 over y times x plus 3. And then once it's factored, you can kind of see what to do next. You're going to reduce, okay? We haven't really done anything with reducing radical expressions this semester in college algebra. That's something that you do in intermediate, and I think a little bit in beginning, but we don't really cover that in college algebra. In fact, we don't really use it until we get here. So we do see a common factor. The x plus 3s are common. We can cancel those. We'll scoot up just a little bit and be able to write our final form. Let me see. I don't think I'm going to need the brackets this time. I can just use parentheses because all I've got on top is an x minus 3. And then on the bottom we just have a y. Okay? And that's where we wind up at the end. Not everything's going to factor and cancel like that, but if you do see a part that will factor, go ahead and factor it and see if there's anything on the denominator or back in the numerator that you can get rid of.